So, this is week 6 of our Stale Neuro book. I will try to combine a few chapters of what we need to focus on and think about. I'll try to focus on the highlights, but please try to skim over the book, highlight whatever you need. There's a lot of information in there. I'm going to pick and choose stuff that we really need to know. And so let's go over draft and venting. So we said before that every pound of oil requires 15.4 pounds of air. So totally we have 15.5 coming out of the combustion chamber. So draft is defined as the suction into the chimney. So if you have a chimney, you will pipe your vent into the chimney, the house chimney. If you don't have a chimney, what are you going to do, Louis?
If you have a chimney,
If you don't have a chimney.
you put it through it now.
Yeah, you put your own vent for the boiler. So draft is suction to air. We have natural draft, torrential draft, forced draft, and direct venting. Yeah.
The first point, I don't know if I'm reading that wrong. Where it says every pound of oil requires 14. I don't know if I'm reading that wrong. What is that?
It's if you burn 1 pound of oil,
Okay.
you will need equivalent amount of 14.5 pounds of air
Okay.
as a ratio.
What does it say under that? Totally 15.5.
So totally, in total, you'll get 1 plus 14.5.
Oh, okay.
So totally, you'll have 15.5 of combustion air, combustion air draft coming out of your chamber. So you'll be blowing in 14.5 and you're burning 1 pound. So probably that's, if you, 1 pound of oil is around 1/8 of a gallon. That's just to give you an idea of how much air you need to vent and how big of a vent you need. So natural draft happens just because of buoyancy. Hot air rises, cold air sinks. So it should go by itself. That's natural draft. Torrential draft, what is that?
Just from high
Suction.
and low pressure?
Yeah,
So
for
it sounds like.
pressure difference. If wind goes through your house, you have torrential draft, and negative pressure will pull things from your chimney, and that's what causes exfiltration or infiltration, because there's a lot of negative pressure coming through torrential draft. So if I want to illustrate that a little bit,
I mean, that's why we have wind, high and low pressure differences in the atmospheres, right?
sort of, yeah. That's why you have wind, low pressure and high pressure. Air moves from low pressure, from high pressure to low pressure. So if this is your chimney here, and you have wind coming by, you will have low pressure in here, and eventually it will pull things with it. That's torrential draft. Natural draft occurs when there is no wind, just by the buoyancy of air. Forced draft is when you put an inducer fan and pull air when you turn on the boiler. If you go in the back of the shop, we have, most of those boilers are installed with induced venting, because they did not calculate how much air being pulled out of those vents, so they just make sure they have induced vent. Direct venting, that's when Louis said, like, we vented outside. So what happens if you have forced draft and no damper door? You cannot have one of these in your vent and you have forced draft. What will happen?
We're gonna create a vacuum.
You'll pull more air through the chamber, and probably you'll run out of flame. The flame will be extinguished. It's like when you're blowing in a candle. So that's why you need this door to be functioning correctly. If you turn the inducer fan, this will be open all the time. If it did not open, you're going to pull air from the chamber, and that will cause you to have no flame. So again, this is one of the most challenging item to troubleshoot. No flame or delayed flame. Why am I not having flame? So I want you to think about the draft as an issue. It could be an issue why you're not having flame or losing flame. So there's a lot of sequence of things you have to do to find out why there's no flame. Could be the cat cell, has an issue, it's covered, could be the nozzles clogged, could be the ignition, it could be the draft. So think all the combustion equation elements, air, fuel, and spark, and see which one is missing, which one is not balanced, and go and check. Eventually, you'll find out. There's a video actually where you see how draft can cause you to have low flame or no flame. Okay, we talked about, this is my damper, where you have excess air going to the chimney, and here where we have the combustion air coming in into the chamber. So natural draft happened by the current of the air going up. The longer the chimney, the slower. There's an equation for how long the chimney is it adequate enough or not to vent. If it's too long, you might have to do forced draft, because the air might not be able to go all the way out. As it goes out to the chimney, it will cool down and it will lose its buoyancy. It was lighter, it was going out, but if it's very long, as it keeps going, it will lose temperature and eventually it will be stagnant. So long chimney can work against you sometimes. You have to know, have a chimney that is sized correctly. Draft pressure difference, hot and cold air in a house, and infiltration. Wind changes your pressure difference. New versus old construction. Again, we said if you are going to place your boiler in the basement, you want to make sure that you have enough air coming in. And when in doubt, just provide your own air for the boiler. Otherwise, it's not going to function properly, and it might also lose flame. So this is what causes draft. And think of draft in a room. Either you have holes in the room, either you have a fan in the room, or you have wind outside. If you have draft, there's a hole, there's an opening, and there's a pressure difference. Question, how do we use draft?
What about forced draft and direct venting and induced draft?
Yeah.
Difference or the same, pretty much?
It's better. It's
What
better
about-
if you have your own incoming air from the outside, and you have your flue pipe goes to the outside, induced. Grant that you have one of these in your vent. Otherwise, you're gonna pull too much air from the chamber. But if you have this, again, you're gonna have to have some makeup air. So you have to open something in the room to put the air in.
There is sometimes a pipe in pipe, like
Yeah.
outside part where air go in
Yeah,
and inside part
Yeah.
smoke goes out. It's
Yes.
like called what, induced?
yeah. Now this is it's not induced. It's just like sealed installation. You see this for condensing boilers. You see those for water heaters. There's a pipe inside a pipe, just so we don't have two holes. One will bring in, one will come out, and it will be enough and sufficient for that appliance by itself. It's an easy way to do it, and it's calculated to run without even power. But it is based on the size, and usually the intake is smaller than the flue pipe. But they have a pipe inside the pipe. You see that a lot. We talked about that, hot air and cold air. And how if you have a cold day, you might have a lot of heavy air in the chimney, so it will be easier for the hot air to rise up and vent. But if it cools down before it goes out, it's not going to go outside and will just accumulate in your chimney. So this is again connection to the house chimney, and how you always have to have some kind of makeup air coming from the house into the basement. Otherwise, this room will run out of air. If you don't have this kind of venting, either a basement door, you might have to make an opening for it, or you have to bring in air from the outside. This is how it works. Again, supplemental air. That's if you have too much negative pressure here, you want to supplement air from the room, not from the chamber. This is some calculation, just to show you the chimney temperature and the height in feet, and you want to be within those specifications. So, for example, let's see what it says here. It's table 6, I'm going to look at it in the book. Those are good because it will give you the general rule to see if this chamber, this chimney is good enough or not. Case one. And if you look here, it also depends on the outside temperature. So if the outside is 60, which means it's cold air, this is what you will have as a draft inside your chimney. And this draft actually is in pressure, inches of water. And in case two, if this is 0 outside, this is the draft you'll have. So you'll have more draft if the temperature outside is 0, because the air is completely cold, and the difference in temperature is very big. And this is the draft calculation, you need to worry about that, but this is what you want to pay attention to, how much draft you need. And the minimum draft you want to have in your chimney is 0.01, that's the minimum. Difference between the chimney and the chamber. That's how fast the air is going. So if you go to a house and you know your chimney temperature is going to be 400, you measure how tall your chimney is, and this is your draft, and it's acceptable at that temperature. And if you go here, it still did not change. No, actually it will change a little bit to 400. So this is a good way to see if that chimney is adequate. If it gives you less than what you need, probably you'll have to put your own incoming air. And you see a lot of houses now, they just try to go without dealing with the chimney, and they go outside and vent completely outside. Conservation of mass, that's something you need to kind of try to understand. So if I have air coming in here, so logically speaking, the flow rate coming out of this opening here should be the total of those two. We said before, flow rate is area times volume. Granted that air is compressible, so it will change density based on temperature, right? But if the flow rate coming out of here is less than the flow rate, the total flow rate between 1 and 2, you will have the flow coming all the way here to here and not to here. So just to make things simpler, this opening should be larger than the total areas of both openings. So
You said it should be larger than the total area
Yeah.
of both.
make sense? If this is a little bit smaller than it's supposed to, and you have a lot of induced draft coming from here, you'll have some back draft coming into 2. And when will we have this kind of issue?
Is that supposed to be 1 and 2?
Yeah, 1 and 2 here.
Alright, you wrote 3. So I was saying that.
1 and 2. How would we have that if you have a boiler for house heating, and you have hot water here? If you want to connect 2, make sure that the area coming out is the total of those. Because again, pressure goes to the path of least resistance. It's like electricity. So think about that when you try to install. And I don't want to say too much in this, because we're going to do some math in the other class when it comes to piping. Same thing with water. If you have 2 pipes, again, the trunk is smaller than both pipes, you're going to have backflow, and that's really an issue. Why do we care about backflow?
No more smoke.
Exhaust, CO2, carbon monoxide, it's poisonous. Excessive draft can cause increase in combustion air, which is not a good thing. If we do not have complete combustion, we'll have incomplete combustion, which means you'll have products that you don't want. And there are so many products that you don't want that burn at different temperatures. So you want to burn at the right temperature, otherwise you'll get different products. We can, if we have increase in filtration, we can put dampers, we can put draft regulators. So in some of the yellows and Viessmann's boilers, the damper actually is changeable. If you have too much air, you can change the dampers. It changes actually automatically, it has a small little damper in it. For our type of buckets, what do we do if we have too much air? We can adjust the air band, right? This is how we install dampers. They are very simple mechanism that can be put on the vent. It's called swing door with counterweight. And I want you to go and check that when you, next week when you do live wiring, check it is functioning, it's not stuck, and it can move freely. And this weight actually is adjustable. So when you turn off, your boiler should be shut, but when it starts to run, it should open a little bit and let some air in. Okay, so this is our draft gauge. What does it do? It's very sensitive to negative pressure, and we will need to use that for our combustion test. It's very essential for you to measure the draft and make sure you have the right draft in your chimney. So over the combustion chamber, so when I go and stick this inside the combustion chamber, and this is the only thing you stick in the combustion chamber. You do not take smoke from the combustion chamber. All the other measurements you take from the breech, which is the pipe coming out of the boiler. So if you look here, your breech is going to be here. You have a pipe, and you can do all the measurement here. And if you see here, there's a hole, a small hole that's designed for you to put your equipment and take some measurement. It is a good practice to cover this hole and you finish with some aluminum tape, just for prevent things from coming in. If you look on the side here, there is a hole in here that you can open up. And you can take your draft measurement. Why do we care about the draft measurement inside the chamber? Because we want to see how much air is being drawn into the chamber. And that's supposed to be between 0.01 and 0.02 inches of water.
It's not negative,
Huh?
because you have a minus sign in front of both first numbers there.
Yeah, negative one, it's negative pressure.
Okay, it's
Yeah.
negative.
And it should be somewhere around here, negative sign, so it's negative pressure. Should not be positive at all. And I will show you how to use this instrument. It has been the same since God knows when.
Big cheap.
Yeah. At the breech, where's the breech again? It's outside. At the flue pipe, should be between -3 and -0.7. So if you subtract between them, you should be getting something between 0.02 and 0.05 as maximum difference. So again, for smoke test, for temperature, you do not go inside the chamber. The only thing you put inside the chamber is what? The draft. So please remember that. I'm gonna keep repeating it because it's very important to know how to do combustion testing. Combustion testing is very important, and you can do it either manually using mechanical kit or electronically, and sometimes it's really good to verify using both. Chimney sizing. So that's again another general rule. Write that down because you need it. 1 square inch for each 6,500 BTU input and not less than 8 diameter. So 8 is the beginning. You're gonna start with 8 inches in diameter. Okay, those two. That's not the dark door, that's the, actually this is 8 inches. And the breech should be at least 8 inches. It could be bigger, not smaller than that. But for each 6,500 BTUs, you need 1 inch. If it come out to 6 inches, you go with 8. So 8 is the minimum, you keep going. Question.
Is that the only thing in that? Is that the only bullet point in that one? Or is there gonna be more, but, okay. Yeah, I was just trying to make sure it's like.
So when flue pipe is replaced, make sure it is the same size. When you place it, do not change the size. Seems kind of intuitive. If I will try to use 45 degrees elbows. So if I'm going from one location to another and I have to have some kind of diversions, I'll do a 45-degree elbow, not 90. Why?
It doesn't interrupt the flow as much.
Yeah, it does not take out a lot of pressure, you don't have a lot of stagnation, and it's less turbulence. So 45 degrees elbows are recommended, and it's also good to pitch upward to have the flow go out. Draft regulator should be at least 10 to 12 inches from the primary control. So if it just happened that you have your primary, I don't know why would you have that, but you should not have your draft regulator close to your primary, because again, draft regulator will hold in some air. But it has been mentioned, at least 10 to 12 inches from the primary control, because there are ways we can put the primary very far from the burner. Must be 18 inches away from any combustible wall or material. So 18 inches from any cardboard, wood, so make sure like it has its own support and it's away from any combustible material by 18 inches.
What should?
The chimney and draft, and I mean the vent pipe.
Oh, then.
Good? So this is again another useful table. And it goes with a chimney height. If you're going to connect to a chimney, let's say we have 8, the chimney should be 15 feet or less. If it's longer, what will happen? The air is not going to flow. It's gonna cool off and come back again, which you don't want. Chimney height is 16 or more, then we have to have bigger size. So the only reason we don't want to connect to a very tall chimney is the air has momentum when it's hot. As it goes out for a long way, it will lose momentum and cools off, and it's not going to vent outside the house. And chimney is made out of bricks. It absorbs a lot of, it actually let go of a lot of heat. It gets cold, especially if you don't have a fireplace going to keep the air coming out. So this is something you wanna like look at and know that the length should not be too much. 15 feet is, that's pretty, not that big. It's 2 stories. So probably in this case you have to either have a bigger one or have to do draft. Sorry, increase the size and have more flow. So this is another question that you might see in the oil burn exam is if you were to use 2 appliances that are exhausting to the outside, they call this the Y connector. So make sure you connect them with a Y connector. This is the Y, and it looks like a Y. And again, the size of those 2 are almost equal or less than the total size of this pipe. And again, you want to be pitched a little bit upward. And this picture is in your book. It's page 6-13. This is another case if you don't want to connect it together, they both have to be connected separately, which means you have to dig 2 holes for each one of them. And also there's a ratio for the pitching, so you want to be a little bit raised. And look at this, it says the firing rate for the larger appliance should be in the bottom. Why is that?
Should be what?
At the bottom of the smaller appliance.
Oh, what'd you say before that? Higher, what?
So whatever has higher firing rate should be lower than the smaller firing rate. if they're not connected together. Why is that? Because this is going to blow up more hot air.
Yeah.
So if this is blowing more hot air in the top, the little one will be blocked. It will not have enough
Oh,
venting
yeah.
to go through. And I've seen this at least 2 or 3 times in installation.
Cause it's denser than the air above it, so it
Yeah.
basically hits a wall and stops.
It will hit a lot of flow in here, so it's not going to vent very well. So these are very, really nice, small little trivial information, but they make a big difference when it comes to troubleshooting. And again, not because something was running for a while and stopped running, that you should not go and check the installation. Chimney check. So please, at any inspection, check the chimney. Make sure it's not blocked. A lot of things get into the chimney. Birds love to live in the chimney. Things get dropped in there, and there's sometimes buildup from 40 years that becomes like stones or cakes inside that has to be manually removed. So go with a flashlight and try to check the chimney from the bottom, from the top, and make sure it's clean. And again, dirtier chimney accumulate more stuff than cleaner ones because they have more surface area for the debris to accumulate on it. So visually inspect for debris. Draft test, that's when we go with the draft tester and check our draft. Inspect the pipe for damage. I'm trying to shake it a little bit, make sure it's not loose, it's not like blowing a lot of air. And if you have a smoke tester, that's very, very useful. You know those little instruments that they make lots of smoke. It's a good way to see and visualize flow because air is really hard to detect. That's why sometimes they stick pieces of tissue and vents to see if there's air flowing right. So the smoke is a very easy way to go and check that draft. Yeah, also go from the outside and check the chimney for obstruction. Make sure there's no bird nest in there, there's no tree, just like grow a branch right in front of it, and it's free to vent the outside. Also check for water condensation. If you have water condensation, that's an indication of what? Lance? If you have water in the chimney, what does that mean?
It means that there has to be water
Low
coming from
temperature.
somewhere.
Yeah?
Maybe there's something, you know how there's supposed to be something that like filters out stuff that exit out the chimney and stuff like that.
So it could be rain.
Yeah, maybe it could be rain that
What
comes
else?
through it.
Could we water the tank that gets burned and put it in the steam?
Could be. What else?
Low temperature with the flue gas.
Flue pipes have lower temperature, or the chimney temperature is very low, meaning that by the time the air comes out, it cools off and condensate on your chimney.
Yeah, I was just about to.
Backdraft. Backdraft, condensation, and that's something you don't want. So it's not necessarily always rain, sometimes it's condensation from your combustion, because what are the 3 things you get out of combustion as an output?
Heat,
Heat,
carbon dioxide.
CO2,
Water.
and water. So there's water, and there are some other stuff dissolved in the water, so you're going to condensate water.
If you have a chimney, how often should you get it checked?
Every inspection, which is once a year,
Okay.
visually.
It often should be swept.
Huh?
Often should be swept.
Well, we never need it, depending how much you use it. And if you have a chimney connected to a fireplace, probably you have to sweep it more often. And usually, for our interior purposes, that doesn't take that long. I mean, back in the days when they used to burn coal, there's a lot of accumulation, a lot of residue. Now we have very good combustion, so it's really hard labor you need to deal with that. So this is a very good illustration of how where vent should terminate. So let's look at that, and it is hopefully in your book. Yes, it's in page 6-16. So vent hood is actually coming from furnaces. You can install a furnace sometimes upstairs at the oil tank, but you can put the furnace there. And it should be pointing downwards. This one must be at least 1 foot above door or windows. At least.
So what about that other one that's like right next to that one right there? Is it really like a foot?
It should be a
down
foot from the window.
Like, below the window, it's not really a foot.
I don't know, I didn't math measure, but they say they start to illustrate how far it should be. And sideways should be 4 feet from any opening. The top, a different situation. Usually hot gas is gonna blow upward, not downward. So the main concern is you don't want that that air to go into the window. So at the bottom should be 4 feet. And, let's look also on page. If you look at, this is like the clearances for each vent, 10 inch from anything, any object, 10 each side, and 20 from the front.
Feet?
Feet, yeah. This is 10 inches. This is 20 inches.
Oh,
Hold on, let me see.
yeah, it can't be 10 feet because the window is only, from doors and windows is 1 foot, and from an opening is 4 feet, so it's gotta be inches, right? 28.
So this is 10 feet from any object or clearance. So let's look at that.
Object.
What is defined as object? No wall, from any wall, from any
No wall.
obstruction. Yeah. I think an object is a wall or an appliance or something else. Not an opening.
Can you go back one page?
Yeah, and from corner,
See, from inside corner, we have only 3 feet. It's
but that's the
doesn't
corner.
work.
So
But
from
it's
corner
not
is,
clearance.
it requires
Oh,
3,
recommended 10 feet.
at least 3 feet from inside corner, recommended 10 feet. If you look closely here. This is your recommendation here, and this is the minimum. And it's good to refer to this page whenever you are doing installation. Okay. This is from the CMR. That's the Massachusetts code. I took this from,
57,
huh?
is that 50?
I think so. No, 7,
571, I forget.
571 or something. I have it in
That's a
blackboard.
CMR one.
But these are the clearances for based on the types, and A, B, and C, 2 feet, front 24 inches, and this is the configuration how you, if you vent it through a wall, if you vent it to upstairs, through the ceiling, and they have it in inches and meters. So D is the rear, because you don't want the boiler to be stuck to the wall. How much do you need to have in the back? 6 inches. And that's something you wanna check with the new CMR, because this is from 3 years ago.
Front, 24.
Okay, let's watch a video about venting. What you think? Okay, let's start.